Okay, today we are going to speak about some concepts about time series forecasting. So these are very important concepts to start with. Time series forecasting is performed in nearly in every organization that works with quantity data. Retail stores, for example, forecast sales and others. Energy companies forecast reserves, production, demand, and prices. Educational institutions forecast enrollment, like universities. Governments forecast sales or tax receipts and spending. International financial organizations such as World Bank, they'll look at the economic activities. Passenger transport companies use time series to forecast future travels. Banks and lending institutions also forecast new home purchases. Venture capital firms forecast market potential to evaluate business plans. So forecasting exists in many businesses. So we are going to go over, or we are going to use notations in this class. T, usually the value of T, it's the index that refer to the time period of interest. Like T equals 1 means we're speaking about the first period in the series. So what is 1? 1 could be the first month or first week or first day, first minute or second. So it's a first period, and the period can be a month, day, week, minutes, etc. Then the y values, y1, y2 up to yn, this is the series of the n values measured over the time and time period. So yt can be, or yt can be maybe the sales, maybe the profits, maybe the temperature. For example, for a series of daily average temperature, T1, 2, 3 represents day 1, day 2, day 3, and y1, y2, y3 represents the temperatures on day 1, 2, and 3. Then in many books, they use F to represent the forecasted value, F sub T. F sub T. So F sub T is the forecasted value for the time period T. F sub T plus K is K step ahead forecast. So when the forecasting time is T, then T plus K is the next period. So you're forecasting for the next time period, which is T plus 1 or T plus 2, the following year or the following month, etc. And there's a difference between the forecasted value and the actual value, because if you plan to do some forecasting for next year, you're going to have a value. Then next year, we're going to have the actual value. Then the difference between these two values, we call it the forecast error. So the forecast error is the difference between the actual value and the forecast at time t, which is yt minus ft. Then the question is, what is the process of the forecasting? So the process of the forecasting, this diagram shows us a process. This is a general diagram, general process. Different institutions maybe go over different process, but this is a general and good process to do forecasting. So the process of forecasting begins with a goal definition. We have to know the goal. We have to start with a goal. What kind of forecasting you're doing? What is the goal? So setting the goal is the first and most important step to start with. After that, the data is collected and cleaned. This is important in data analysis. Then we explored the data using visualization tools. Then we set a potential forecasting method. So once you goal, you clean your data, you've seen your data, you have to say, okay, what kind of forecasting methods we're going to use. This is based on the nature of the data. So the different methods are applied and compared in terms of forecast accuracy and other measures related to that goal. Then the best method is going to be chosen to generate the forecast. So you apply many methods, then you choose the best one based on the accuracy, right? So the process doesn't end once the forecast is generated, because the forecasting is an ongoing goal. This is something that people do not know. We keep doing forecasting because the forecast accuracy is monitored, and sometimes the forecasting method is adopted or changed to accommodate changes in the goal or the data over the time. And if you notice in the diagram, we have two sets of arrows. These arrows indicate that the process are iterative. So we keep getting the data, explore, visualize series. This is ongoing. Because if you explored your data, sometimes you are going to say, hey, I'm going to get more data. Or when you visualize your data, sometimes say, hey, I need more data. So you go back and collect more data. Or the other one, the next one here. The next one, sometimes you say, hey, I applied the forecasting method and evaluated the performance. Then I have to do this again because I'm going to look at other methods and so on. So these two steps actually are iterative steps. Finally, you just implement the forecast on your system. Maybe next chapter, and this chapter, we are going to talk about Amtrak trains. This is going to be an example. We have data collected from 1991 to 2004. So this example is going to stay with us. So we start with the goal definition. So the first important thing that you have to determine the purpose of generating forecasts. So the type of the forecasts are needed, how the forecast will be used by the organization, what are the costs associated with the forecast errors, what data will be available in the future, and others. Also, forecasts do not exist in a vacuum. This is important. So they actually affect different stakeholders in different ways. Some people may trust the forecasts, while others, they suspect the biases or manipulation or hidden motives. Like USDA publish a forecast of corn and soybean yields. The forecasts influence whom? Farmers, traders and markets, consumers, and government programs. So if the stakeholder do not understand the forecasting methods, they may assume, oh, there is a manipulation here. And if you have a lack of trust, this can cause markets to overreact or underreact, or farmers to make poor decisions here, policies to be misunderstood or resisted. So the bottom line, when you produce forecasts, you must think about how different group of people will interpret them and how they're going to react. So transparency is important here. Other than the forecasts may fail their goal, even if they are statistically accurate. We have two types of goals. So the first type is descriptive and predictive goals. The goal is, the descriptive that focus on analysis. It's just describing. It's like statistics. You're just describing what's happening. You are not doing any future forecasts. You are not doing any forecasting. You are not predicting what's happening. You are just analyzing the scenarios. So that goal is identifying structure, trend cycles, and others. This is used if you want to make a decision for policy explanation. So usually they use very simple models here like regression. If the goal is a predictive, so you're doing forecasting, that means you are generating future values. The first one, we are not generating future values. But this one, we are generating future values, and this is used for planning for the future, inventory control, let's say, or maybe financial forecasting, sales forecasting, etc. The models here, the accuracy is important because we are just thinking about the future, right? So the accuracy is important. So sometimes we're using machine learning techniques in this case. And these two goals are referred to, or there are two words are connected to these two words. The descriptive, we call it retrospective because we look back, and prospective because we look ahead, we look forward, right? And we forecasts unknown for the predictive. The forecast horizon. The forecast horizon can be short-term, can be long-term. What is the horizon first? It's the number of periods ahead. So F plus 1 is one step ahead. FT plus 3 is 3 steps ahead forecast. The example that we mentioned at the beginning and we're going to use in the future, that Amtrak trains, maybe they're going to have like a short term, which is a 1 month ahead. So this is useful for revenue management, setting tickets prices, or other short-term forecasts. Sometimes they're having long-term or longer term forecasts, let's say 3 steps ahead. And this is going to be useful if you're doing scheduling, because you're like planning how many trains or staff are needed in the future. What is the impact of the data timelines here? So forecasts rely on the latest available data. So if your data is delayed, then maybe you're going, you cannot do ft+1, let's say, because you don't even know t if your data is delayed. So in this case, you have to think about doing ft+3 or ft+4, and this makes your forecasting harder. So at the beginning, you have to know this. If you are doing at the beginning of the forecasting, you have to know the goal. The goal definition stage is important. So the question is, can we improve the timeline of the data collection? Because if you improve the timeline, then you can improve the accuracy probably and uncertainty here. So the further ahead you forecast, by the way, the less accurate it's going to be. For example, if you are today, let's say Tuesday or let's say Tuesday, and you're making sales, and if you would like to forecast tomorrow, it's going to be easier for you because almost every external factors. Tomorrow is going to be the same weather, it's middle of the week, there's no rush. I mean, the same situations and the same thing of today. So in this case, what you are expecting or what you are forecasting is it's going to be more accurate than if you do forecasting next week Tuesday or the following week Tuesday. Because why? Because the world is changing, like new events, policy shifts, shocks next week, next year, etc. Right? So the good practice is you anticipate these changes in the model and regularly check if the model is still valid and keep updating the model. Updating the model, we call it the roll forward forecasting. Even for long-term horizons, forecasts do not have to be one and done. I mean, it's not just one time thing. For example, if you are in January now and you are forecasting April ridership, let's say the example. So in February, update the February's new data, because in February you're going to get new data. So add them. You're still forecasting April. In March, update again, because you're going to get more data. You're going to get more idea, clearer idea about your April's forecast. So this process of refreshing with new data, we call it, as I said, roll forward forecasting or rolling forecasts. So the forecast use. So the big question that we need to ask ourselves that how well the forecast actually will be used. This is important because it shapes many things. What kind of forecast you produce, what accuracy is good enough, and what trade-offs matter, right? And these are questions that we need to look at sometimes. These are key questions. Do you need to, or the data that you have, or do you need actual numbers to forecast? Or maybe yes or no, like is it numeric or binary? So the forecasting cells, are you looking for the numbers, like how many units are you going to forecast next week? Or just will the sales exceed 1,000 units? Yes or no? The second thing is the cost of error. Is over-predicting worse than under-predicting? Like in airlines, over-predicting demand. So what's going to happen? Too many empty seats, big cost. In hospitals, under-predicting ER visits is going to cause what? Staff shortage, big cost as well. The other thing that you need to look at is direct versus adjusted forecasts. Will managers use your forecast as is, or they adjusted manually? Because they have more experience than you do. Because you're a tech person at the end. Next, you have to look at the audience. Will you present to management or technical staff? Management maybe needs simple and interpretive way of saying things. But if you are presenting your forecasting to technical people, so you have to look at the complex method and use technical jargons and equations, etc. So the idea is knowing how the forecast will be used ensures you deliver something practical, not just statistically good. Level of automation Also, we have to look at many questions when we think about the level of automation. How many series? So the level of automation is about how much human involvement is needed in the forecasting process. So how many series? Is it just one, or we have thousands of series? Is it every product in every store? Look, every product in every store. Absolutely, we need the automation here, not you. Is it one time or ongoing? So one-off forecast for a project or regular weekly, monthly forecasts? What data software is available? Do you have Python? Do you have R? Do you have specialized software, or just you have only Excel? Because Excel is not powerful enough to do all of these complex analysis. And what expertise is available? So do you do the forecasting you yourself? Do you have a team with you? Non-experts are there? Then you have to look at the implications. So if you have many series, ongoing forecasts, little expertise, then automation is important here. Like you use automated softwares, right? So automation decision depends on the scale, frequency, and data or software availability, and who is going to maintain that system. So this is everything about chapter 1. Next week, we're going to go over chapter 2. Thank you.